Hello class, in this video we are going to look at our student math journals, page 32, answering the first three questions. Okay, so here's the first one. It says in problems 1 through 3, use the mathematical models to estimate the volumes of the instrument cases. So here's the instrument case, and it's a complex shape, and what they've done is they've taken and kind of made it into two shapes that are roughly the same size as the one in the picture. So this is not square or rectangular like this is, but they've made it close, and because we're just asking for an estimate, close is okay. And again, it has some sloping sides. We didn't include that, but we've got the basic shape. So if we can determine the area of this long shape and the bottom shape, add those two together, that would give us a reasonable estimate for this shape. So let's go ahead and do that. All right, so here we have the top shape. We'll do that first. It's 31 inches by 8 by 4. So I'm going to take that 8 by 4 and call that 32 as a base. And if I have the base, the volume for the formula for volume is base times height. And so if I take this as my base, 8 by 4, that's 32, and my height is 31, and I multiply those together, well, 1 times 2, 1 times 3, 3 times 2, 3 times 3, add my two answers together, 2, 9, 9. I get 992 cubic inches, but that's only the first part, okay? I do have a second piece there that I can go ahead and estimate for, so let's turn this around. And let's do our math for the second piece, which is 9 by 10 by 4. Okay, well, I'm going to do this one. I'll do volume equals length times width times height. I'll take all three measurements. 4 times 9 times 10. And that is equal to 4 times 9 is 36. And when I multiply a number times 10, 36 times 10, I put another 0 on there, I move the place values over, and I get 360, and again, that's cubic inches. Okay, so I'll put the unit there. So now I have both measurements, both volumes, both pieces, and all I got to do is add them together. So 360 was one, 992 was the other, add them up, and I get 1,352 cubic inches for my first answer. Okay, for the second one, we've done the same thing, taken two shapes that are close to the right size, but we've made them into simple shapes, and then we can just add the two areas together to come up with the area of our complex shape. So let's do this front one first. It's 14 by 14 by 6. So let's do length times width times height. What is 14 by 14? 4 times 4 is 16. That's 56. That becomes 14. So the area of one piece is 196. The area of the second piece, 15 by 4 by 16. Well, 15 times 4, I can count that as a base, because that's pretty simple. If I know that 15 times 2 is 30, then I know that double that times 4 is going to be 60. So my base is 60, and I'm multiplying that times 16, my height. So that's just a 0 placeholder there, because 0 times 6 is 0, and 0 times 1 is 0, so I'm moving everything over one place value. And then I have 6 times 6 is 36. 6 times 1 is 9, plus 3 is 12, and I get an area, or excuse me, I get a volume of 1260 for the second piece. So if I take those two and add them together, all of a sudden I think to myself, something's wrong here. Why is that one so much bigger than this one, when they look like they might be different sizes, but not quite that different? And the answer is because when I multiplied base times height, okay, this wasn't the base, it was length and width, so I still have to multiply the 196 times the other measurement, which is 6. Hey, let's see. I love it when I find out that something doesn't make sense and I can go back and correct my work. But in order for me to do that, I have to think about the process of what I'm doing and try and make sense of the numbers. Okay, so 6 times 6 is 36. Carry the 3. 6 times 9 is 54. That becomes 57. Carry the 5. 6 times 1 is 6. Plus 5 is 11. Oh, that looks so much better because those look like they could be similar in size. And now they're similar in volume, so it makes much more sense to me. Now I just have to take both of those volumes, 1260, 1176, add them together, 6, 3, 4, 2, and I get an answer of 2,432, again, cubic inches. So there we have number 2. Okay, for this next one, at first it doesn't really look like an irregular shape or a complex shape, but when we take it apart, this comes in an angle, okay, because a xylophone gets smaller on one end than the other. So what they've done is they've just, instead of putting it as triangles, they just came in a little bit each time. So for this one, we're actually going to have to find 3 simple areas and add them up to get the area of our complex shape. So what I've done here is I've just applied the formula for each one, length times width times height. Here I have 24 by 15 by 5, 24 by 15, and I figured that came up with 360, and I multiplied that times 5 because there would be 5 layers, came up with 1800. Did the same thing for the middle section, which is 18 by 15, 5 units high, came up with 1350. And I did that for the third one, which is 12 by 15, 12 by 15, okay, and that came up to 180, and it was 5 high, so that came up to 900. Now that I have all 3 of those volumes, all I have to do is add them together. 1800 plus 1350 plus 900, 0, 5, 0, 4. So it looks like I came up with an answer of 4,050 cubic inches.